this video we will learn how to solve a system of equations using matrix inversion method. The question is find out the value of x and y from the following equations using matrix inversion method. We have two equations, 2x plus 3y is equal to 5 and 5x plus 4y is equal to 6. We need to find out the value of x and y using matrix inversion method. So first thing is we write these system of equations into matrix form. That is in this form a x is equal to b. Now what is a? A is the coefficient matrix, x is a vector what we call the solution vector, and b is the vector of constants. And let me explain it here. So a is the coefficient matrix, the coefficients of x's and y's in the two equations. Coefficient of x in the first equation is 2, in the second it is 5. Coefficient of y in the first equation is 3, and in the second equation it is 4. So this is the coefficient matrix. Now x is the solution vector. That is we want to find out the value of x and y, so we call this the solution vector. Now b is the vector of constant terms. So we have 5 and 6. Okay, so first thing is to write the given system of equations in matrix form. Now to solve it using the matrix inversion method, so the formula is that x, that is the solution vector, will be equal to a inverse times b. Now to find out the a inverse, we need to find out the adjoint of this matrix A. Okay, so before we find out the adjoint, we need to find out the determinant of the coefficient matrix. Okay, so what is determinant? A determinant is simply we multiply these two elements, the principal diagonal elements. So 2 4s are 8 minus 5 3s are 15. It comes out to be -7. So the determinant of A is -7. Now to find out the adjoint, what we do? Adjoint of A of this matrix, what we do? We swap the principal diagonal element, so it will be equal to 4 and 2, and change the sign of non-principal diagonal elements without swapping them. So it becomes here -5 3 -3. Okay, simple thing to find out the adjoint of a 2 by 2 matrix. It is very simple. What we do? We swap the principal diagonal element, so 2 goes down and 5 goes up, and we change the sign of the non-principal diagonal element. If it is positive, it becomes negative. If it is negative, it becomes positive. Okay, so this is a shortcut. Otherwise we have to find out using minors and cofactors. Having said that, okay, now what will be then A inverse? We need to find out A inverse. A inverse is equal to 1 upon the determinant of A times adjoint of A. So determinant is -7, so we can write A inverse is equal to 1 divided by -7 times adjoint is 4, -3, -5 and 2. Solve it. That means, so here we have -7 rather, so we need to divide -7 to each of these terms. So we will get 4 upon 7 here. Here negative into negative positive, we get 3 upon 7. Here we get 5 upon 7, and here we get -2 upon 7. Okay, so this is our A inverse. Now what is x? X is in fact our solution vector that we are trying to find out the values. It is equal to A inverse. So A inverse is this: -4 upon 7, 5 upon 7, 3 upon 7, -2 upon 7. To this we multiply vector of constant terms, that is 5 and 6. Okay, now we need to do, that means x, y, so solution vector will be equal to, so we multiply the elements here. So how do we do? We multiply row with column. So first we multiply this row and this column. So we have -4 upon 7 times 5 plus 3 upon 7, 3 upon 7 into 6. Okay, this row and this column. Then we multiply this row again with this column, this with this, so this goes here. Likewise, we need to multiply this row with this column, so we have 5 upon 7 times 5 plus we have negative 2 upon 7, negative 2 upon 7 into 6. Okay, so how did I did the multiplication here? So we multiplied this row with this column and write it here, and then we multiply this row with this column and write it here. Okay, so x y will be equal to, so here 4 5s are 20, we get here negative 20 upon 7 plus 6 3s are 18 upon 7 where did I write? I don't have the space here, so it will be equal to, okay, so we get negative 20 upon 7, 18 upon 7, and another is here 5 5s are 25 upon 7, then we have negative 12 upon 7. So x y will be equal to, so we have a negative 20 plus 18, it is minus 2 upon 7, then 25 minus 12, it is 11 upon 7. So the value of x and y is, so x will be equal to negative 2 upon 7 and y is 11 upon 7. Okay, I hope I make myself clear in this video. So this is how do we find out the value of variables using matrix inversion method.